Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik sta hier op TechX met de enige echte
Jan Stomphorst.
Solutions Architect bij.
ACC ICT.
Heel goed, Jan. Je weet het nog.
Onderwerp. Niet Kubernetes.
Waarom je het niet moet gebruiken.
Dat vind ik een heel goed verhaal.
Ja.
Ben benieuwd.
Voel je je al een beetje ongemakkelijk?
Altijd.
Okay, without further ado, we'd like to switch to English and introduce Carl Moberg. Is that correctly? My Swedish accent is not really...
Oh, no, you're nailing it. Perfect.
Yeah, really.
Perfect, yep.
And I was thought it was Avasa.
Avasa.
Yeah, okay. 2 out of 2. Great.
And I'm here trying to understand because it feels like it's so close that I can understand Dutch, but I just can't. But it feels like it's...
Yeah, it's the same with like Swedish and Danish. Yeah. You know, so you hear the pronunciation is almost the same.
There you go, the same sound, yeah.
So, Carl, welcome for spontaneously joining our podcast.
Well, thank you for asking. This was a fantastic surprise, just walking by like, do you want to talk about Kubernetes? Yes, of course I do.
Cool, sorry, this is Kubernetes.
Well, exactly. We'll get to that.
It's told to us, yeah. Can you please introduce yourself to our listeners?
Of course, yeah. So I have a long background in building things. So I used to be a network engineer. That's actually how I started back in the late 90s. And I know you guys have, some of you guys have a Unix background. So I used to be a Unix admin for a service provider. Cool. And the thing that really got me started on the journey towards where I am today is that even in the late 90s, we realized that there is a deep need for automation around about the networks that we used as a service provider and also the email services. So I quickly became involved in a really weird mix of like scripting in the Unix environment and automating the network. So kind of an interesting mix between the two. And that became almost a theme for my career was automation and orchestration. So I eventually ended up in a company that built automation systems for very large networks. And we managed to hit something, a hype cycle that used to be known as software-defined networking. I don't know if you guys remember that. And there you had for a while. And the company was called Tail F Systems, after the Linux command, tail -F. And so we got acquired by Cisco. So Cisco bought us because we had some very large customers. And the whole story around how I ended up with Avasa kind of starts with being part of Cisco for 5 years. And we started talking to a lot of enterprises. And it turns out that they were very interested in automation, but they were not very interested in network automation anymore. They were more interested in automating and orchestrating the applications. And honestly, they were even more interested in automating applications outside of the cloud because they felt the cloud was also like, it wasn't perfect, but they had most of the tools that they needed for pretty smart and efficient lifecycle management in the cloud. But as soon as they needed to run applications outside of the cloud, and we eventually learned that many people call that the edge or edge computing, they struggled really hard because they had no tools, so they had to resort to very manual steps. And that was right up kind of me and my founding buddies' alley. It's a distributed system. We love that. It is a robustness challenge, and it's about automation and orchestration. So he said, that looks like a really interesting topic. Let's see if we can build a system that helps those teams to have the kind of same experience with automation and orchestration that they are used to from the cloud. But now it's companies like retailers that are running containerized or VM-based applications in thousands of locations, right? So that's kind of the founding story here, you know, coming from automation and scripting towards the infrastructure automation. And now what Avasa does is application orchestration and automation for very distributed environments.
Yeah. So, but I hear a lot of Kubernetes-related buzzwords or topics.
Yes. Yeah. So at the heart of it, one of the reasons why we thought the timing was right was because of containerization. So hold the Kubernetes thought, just containerization. I'm holding Jan in his place. Hold. The fact that many of these enterprises, they already had most of the applications that they wanted to run at the edge. They already had them containerized. That was already done in preparation for the cloud, right? So they realized that without that, you know, if they had to run like RPMs or, you know, native Linux applications, it would be even worse. With containerization, they got a lot for free. And this is usually part of my containerization presentations, is to say, it's not just the fact that it's a tar file with some magical content. it's so much more. It's the fact that there's the whole registry repository infrastructure that you can publish and pull things doesn't exist in the VM world, doesn't exist really in a standardized fashion in the native application world in the same kind of
You've got repositories.
yeah, but it's usually very vendor specific or kind of awkward in my mind. So, but for containers, we have that. We have standardized ways of starting them. We have stocking them. We have health probes.
They're
wireless
always the
probes.
same. It's awesome.
Exactly. So when we then started thinking about, let's found a company, then of course we love the fact that we didn't have to invent any of that. We could just take that from the container world. So we didn't have to invent means of starting things or stopping things or monitoring things or picking logs out of things because the kids don't use syslog anymore. They use standard out to the container runtime, right? So we could just stand on top of that instead of reinventing it. You guys are both kind of, you can see in your faces now he's going to go into the Kubernetes talk.
We're waiting for the insert
I'm again there in my own maritime here.
either do the button on this sound, but dun dun dun, like something.
No, so we realized that containers will be at the heart of the system that we build. We're not going to care too much about other stuff like Windows, applications or things like that. Let's do it for containers. Seems like a safe bet. Everybody's doing that. Eventually, we also had to actually if you like, back implement VM support. But it turns out that, as you guys know, you can package VM images in a container, and then you can do clever stuff with KVM. Yes, so we have that kind of support as well. But again, at the heart of the system is container support. And then, of course, comes the conversation. Okay, so in a system like this, there's going to be two components. One is going to be central, some sort of dashboard REST API command line interface thingy. And then you need some sort of an agent, something running that you probably own yourself that runs on all these boxes in all these locations, right? And then comes the conversation about what kind of container runtime do we need? What do we have here? So there were two things that really took us in this direction. And this direction, as you hinted at, is that we run right on Docker or Podman, and we don't use Kubernetes. And interestingly enough, we real. This is, that's where the sound.
Yeah, there is a sound, but I don't know what button, so it cannot mess up outside the thing.
I see. No, the interesting thing, I'll tell you this in all honesty. We really thought we would be best friends with Docker, the company, forever.
Oh, yeah.
Because we thought we could really help them get into the edge world, right? And we would get a lot of Docker runtimes deployed. Turns out that Docker as a company, you guys may know this, have kind of pivoted towards the developer experience.
Yeah.
So they're not super interested anymore in whatever's running, out in the production environment. They're very interested in what's running on the laptop or the workstation, but not the other thing. That took us a while. So if you go back, you can hear me present at DockerCon, for example, about like Docker at the edge and stuff like that. And literally we got the suggestion to go talk to the Podman team at Red Hat instead. So we clearly see actually for most of the verticals that we're in, like retail and industry, people are kind of abandoning Docker, which was the default choice for many years.
Yeah.
And Podman was now becoming the default choice because Docker doesn't seem to care much in general.
Docker's has lost the battle.
The orchestration.
I will say so. Yes. Yeah.
With Docker Swarm and
For sure. And even in cases where Docker is called for, people actually now tend to choose Podman. And we've even seen, like in some industries, we get, you guys know what requests for proposals or RFPs and RFIs and all that, where they explicitly say, we suggest Podman, we expect Podman, don't bother with Docker. So what we had to do though was two things. First, we had to build what we thought was an awesome abstraction. So we wanted the APIs, the REST APIs and the web UI to be very, very comfortable and easy to use and kind of edge specific. And I know we have time, so I'm just gonna say a couple of more words about that.
We're listening there.
Yeah, good. So there are two things that are really important in my mind for edge environments. One is how do you package a container-based application? We could steal liberally from the definition of pods, from Docker Compose and others, but we had to add a couple of things that we think are very important. But the main structure we could liberally steal. We didn't have to reinvent much. Then comes a way more important thing. None of our customers run the same version of an application with the same configuration in all locations at the same time. They always do some sort of selection criteria. Let me give you an example. in retail, they usually have a point of sale system limited to a particular regional area. See what I mean? So when they deploy a point of sale system, they only do it to stores inside of, let's say, Sweden. So they have to tell whatever system they have, here's an application, only run this in Sweden. So some sort of, we call that targeted deployments. But it gets more interesting. So we have a lot of companies or customers that use AI workloads. So some sort of inference, usually a camera pointed at something, camera stream comes in, hits the inference engine, looks at the model, out comes a result. Requires a GPU. So another criteria is to say, only deploy this in Sweden, but only deploy it in a host that has a camera attached and an NVIDIA GPU with CUDA enabled on it. So you start to see that there's almost like a criteria-based placement algorithm here, based on what each box is either statically known to do, the fact that it has a camera attached.
I'm trying to solve that in Kubernetes already.
Yeah. No. And man, I'll tell you this, just to maybe take the edge of this, no pun intended, is if you can tell me how to do that, easy. Good.
Hold your horses.
See, this is great for the listeners. Eventually we'll get to that point. So there's a whole slew of those things. So we understand, or what we hear is that the application teams would like to know a lot about each host and each location so they can place their applications accordingly. And there's a whole slew of side effects to that, meaning if you build a new store and that comes up and it matches a couple of applications, they want them to be automatically deployed. So in our world, there's a holy trio of sites and what they can do, applications and what they need, and what we call deployment specifications, which kind of defines the criteria under which this application should run. Turns out when we tried it, you can't really do that with Kubernetes. And we try to do it two ways. One is to say, okay, let's run Kubernetes clusters at the edge, and let's invent something central. Because there's no, as far as I know, I'm just going to be a little defensive in the language. As far as I know, there's nothing, well, certainly not from Kubernetes. There's no widely available central multi-cluster and application placement engine available at scale. So we would have to invent that either which way. The second thing would be to do something weird, like putting the control plane centrally and then have workers in each location. But now you start to really violate the Kubernetes abstractions. That's not a good thing, right? So that left us with trying to say, okay, let's build our own control plane or configuration plane centrally, and then interact with the Kubernetes APIs in each site.
Yep.
So the first thing was that the abstractions from Kubernetes kind of assumes a lot of local decision making, i.e. you can't really do fine-grained control and override the local control plane, which turned out for us to be a huge problem. So things like local placement, we couldn't do centrally.
No?
It would be left over to the local control plane. So that was kind of the abstraction start. And here comes what was really, really hard. Most of our users today, the reason why they want to put things at the edge, maybe surprisingly, is not for response times, which is what most of the press talks about. It has more to do with the fact that they want uninterrupted operations, right? So in retail, even if the internet link goes down, they need to be able to still sell things.
Yep.
In mining, even if the internet goes down, they still need to be able to warn people not to walk into forbidden areas, right? What that does is that you have to push a lot of architectural components into the local sites. I'll give you the most complex one first, and let's see if you agree. If you have clustering and you do node failover, so a node dies and you need to actually start that application or the containers or another host.
You need a management for that.
No, what you need is access to the registry or repo where those containers are. And you can't rely on upstream connectivity, so you need to have a local registry with the containers that corresponds to what you're running. So this means you have to have a local registry.
Yep.
With Kubernetes, you also probably need something like an OPA for policy, particularly if you do multi-tenancy.
Yeah, multi-tenancy, you need OPA.
Yeah, and local log collection, local log event streaming, you need something like a Kafka or Pulsar. And I can keep going. What you need to do this is about 15 components. So before you start your first application, you're looking at Kubernetes and 15 applications. That takes that kind of scenario out of the idea of running on a single node, for example, much less on a something like a Raspberry Pi, which is pretty common in the industry. And so not only does it blow the resource budget south, the worst thing is that eventually you'll find out, okay, my Falco needs updating. Oh, but the interaction with OPA means that I have to rewrite my Rego files. And you will find that most of what your operations team does is maintain the infrastructure components. This is even before the first application is running. So the operational overhead of managing Kubernetes with 15 other components across hundreds of locations is insane. Enough that we backed down and said, we just can't do that. We can't assume that kind of workload for our end users. So we backed down and said, look, what are the features of Kubernetes that actually isn't Kubernetes but containers? Which honestly, and I'd like to compare notes here where people say like, I love Kubernetes because, and then they say something about containers.
No, it's Kubernetes is a container management platform.
Yeah. But there are very few things that,
It's really small.
I know. But there are very few things that are unique to Kubernetes as opposed to running in Docker that people actually use. Which made us also a little more certain to say, okay, maybe we'll have that conversation because you guys know this, and I told you before, it's not a conversation that we want to run into, begin every conversation by explaining why not Kubernetes, right? But then we started looking at what would it look like if we built it using Docker Podman. We got most of the features like easy failover. We didn't get some of the features for free, like horizontal elasticity, so load balancing, which we've never had any edge customers ask for because that's not how the edge works. It's static hardware, so you never scale above the boundaries of what you have. And again, technically, it's worked out pretty nice. Our agent is about 150 megs. For the technical savvy, it's built partially in Erlang, which is a perfect language for these kinds of environments. It's literally a containerized application, so we run with some slightly elevated privileges on the container runtime. It provides that registry endpoint. It provides a distributed vault-like secrets manager. It provides local log endpoints. It provides, again, Raft-based failover. And it's a single binary that we literally lifecycle manage from the central plane. So any updates or upgrades we do from the central control plane. So there's literally no lifecycle management of the constituent parts of the container runtime local. So it's played out really well for us, except in certain conversations. So that, I don't know, I've talked a lot now. I didn't open up for too many questions. So that's kind of the rationale behind this.
So your solution you were thinking about is still valid or?
Still big. No, it's bigger than 150 megs. But we've got a podcast that's about.
Let's see if it's still. I was thinking about this exact.
So did you interview Brian?
Yeah.
Evers?
Yeah. Yes.
And,
He was a huge inspiration for us to start this, and we've been in more or less constant contact with him since then.
And they're running Kubernetes on the edge.
Yeah.
3 nodes. We've got a complete podcast about that.
Did you ask him the following question? Would you do that again? No. You should try that. You should try that.
He told the story full passion. So
Yeah. No. I think for where they, I'm not going to talk for him, but for where they were and with a fantastic team that he has, probably the right decision. But that doesn't mean that everybody, you guys know it, that doesn't mean that everybody should do that.
exactly.
But you are right. And again, he was a huge inspiration to us. And most of the problems that he laid out was stuff that we had in our initial roadmap. And of course, conversations with people like him. And another fair question is to ask, would you, of course, one of his points is there was nothing.
Yeah.
He had to.
Yeah.
And then the bigger question then is, if we existed, would you have considered us? See what I mean? And that's a more interesting.
Probably.
Yeah. He would, I think I am full enough of myself, even though I'm Swedish, to say that he would probably have looked. He would probably have looked.
The Kubernetes on the edge is also coming. So K3S, that's a small Kubernetes version with lots of tools.
Yeah.
And probably you don't need that much observability on the edge or that much everything on the edge.
It's partially true. So we've spent a bit, we've actually.
For multi-tenancy
Yeah.
on the edge,
Yes.
I think that's stupid.
Well, tell that to the retail chains that we just announced that are doing that.
No, but it's you're doing something on the edge and build more clusters then. It's easier.
I'll give you a good example. So another environment we're in is with point of sales in retail stores. And a lot of retailers don't want to manage the point of sale system, but they want it to run on their infrastructure. So they use something like us. They create a tenant and give the tenant to the point of sales company that then actually operates their software on their in-store hardware, which in my mind is actually pretty awesome sample of multi-tenancy. And that what's hard with multi-tenancy is, for us, we need to scale that down to a single node. So we need to, for example, keep networking traffic cryptographically separate between tenants and between application and their services. Those things, those constructs don't even exist in Kubernetes. They literally don't. It's because, like to your point, it assumes a single administrative blast radius per host, which is for several of our environments, it's just a no-go. It's just
That's then an awesome solution. Then if you would solve that in Kubernetes, you would run Kubernetes in Kubernetes.
Yeah.
And that's blown big and complicated and annoying.
Yeah. So do you want me to talk about what's bad about this choice?
Yeah.
I'll be more than happy to talk about what's bad about this choice, because that's what I come up against too. So honestly, I mean, one of the things that we aspire to, that we love, is that people usually have significant investment in IT operations before they meet us. They've come to build and love things that allow them to automate most of their day, secure most of their day. So they've invested heavily into it. And of course, our basic posture is to try to be non-intrusive. Never ask them to do something different unless we must. And we are also big believers in don't do swivel chair. Like the worst case you can do. So let's say we have a number of customers that are, let's say, AWS or GCP or Azure users. So they spend their day in the Azure, GCP, or AWS dashboards. And a dumb thing for us would be to say, yeah, do that. But whenever it's the edge, you have to swivel your chair over to our stuff, right? So to try to, when you take on our stuff, try to avoid thinking about swivel chair, right? So we've tried to build it so that they can easily integrate with whatever they have. Usually the CD, last stage, monitoring and observability, independent of whether they are like Grafana, enterprise-y stuff, or if they're AWS CloudWatch or whatever, right? So one of the ways that this actually falls apart just a tiny bit, since we don't use Kubernetes, is Helm charts, right? Because we know that people have spent.
I don't like templating for templating.
Don't buy any started. I have a background in schema languages and strict.
But it's now de facto standard.
It is.
So I have to live with it. But
Yeah, and again, whether I love it or not, it doesn't feel good at times to say you have to do something else. We have another way of expressing applications, and that honestly, that doesn't feel good, right? Because we know that they've, again, independent of whether they love it or not, they've invested in it. Yeah, they've made it hopefully to a point where they are comfortable with it, and asking them to do something different doesn't feel good. So, of course, we have little bits of scripts and transformers and stuff like that, but they are different. So we have to ask them to take whatever application that you have, like in a Helm chart, look at our way of describing this application specification, and do that. So that, for example, to me, even if I'm trying to convince them that the value of this system is big, that's a tough one. Like you have to.
can't you write a Helm provider or something?
There are ways that we are thinking about this. The problem with Helm is exactly what you said, though. It's a schema-less or schema-free templating language. So there is literally no boundaries to what you can do with it. So it's really hard to build something robust to do that. So we can do something to kind of one-shot, kind of opportunistic. That doesn't really help too much. It's probably even faster to just, bite the bullet and just do it. But that's one thing that I find is a true maybe backside of this, is that we have to ask people to repackage their applications for the edge. At times, because this is another thing that I think Kubernetes at times even makes it dangerous for the edge, is that it's the abstractions, the way I experience them is kind of assumes boundless resources. And to me, actually working with people that are deploying to the edge for the first time, and I think you will like this particularly with a Linux background, is for some of them, this is the first time they meet the OOM killer. See what I mean? It's the first time in their actual career that they run out of resources. And they come to the deep understanding that whatever their application is doing, it may get randomly taken to the backside in short. Which is...
Yeah, but if you configure your application the proper way in Kubernetes,
Yes.
you will see that often. You know what home killer is.
But do you find that they do that though? I find that they don't. I find that they assume almost limitless resources.
No, my customers or the people who I talk with, they have to. In my company, they need to.
Okay, cool. Then maybe that's because they listen to you.
No. Oh, that was too fast. No, it's if you don't define resources, you can't autoscale.
True.
Because what are you gonna autoscale if you don't know where your limit is?
Where the boundaries are. That's a good point. That's a good point.
So it's something, and if you don't limit, where does your CPU end then? Or what are you getting from the scheduler? But it's so limits are, and home killer is home killer is awesome.
It teaches people the hard lessons in life. Yeah, you may just go away randomly. Yeah.
Who knows? So as an old Linux guy, home killer is awesome. No.
It's just a part of life.
Yeah.
Yeah. So I think that might also be, a thing that people are a little less prepared for. But maybe you're right. I haven't spent too much time, like you do with a lot of people in the Kubernetes environment. But just the idea that you have to actually think about the resources that you actually consume and what it means to consume too much. Because what you hit in, let's look at a a lot of technical people, when they, seems to me like when they close their eyes and think about edge computing, they see what Brian at Chick-fil-A did, which is like a 3-node,
that's
NOC-based cloud.
Yeah.
The interesting thing though is that it's hard boundaries, and you know this, it's physical boundaries.
Yeah.
I mean, it's not an option to ship another NOC. You see what I mean? You can, but that's a big investment, right? So it's not easy to remediate. So resources becomes super, super important, and thinking about resources. And my observation, particularly, so we have two types of customers. We have some customers we do what we call edge shifting. They have a lot of applications running in the cloud, but they realize that a small subset of those, usually a couple of containers, would actually run better closer to the data source. So they carefully lift and shift a small subset into the edge environments. The interesting thing though is that they were born in the cloud, so they're usually super bloated. They don't think about perimeter security. That's another big thing, because if you put it at the edge, the fact that people may actually physically steal the computer that your application is running on is a new idea.
Yeah.
For many software people.
It's a new old idea.
Yes. Thank you. Oh my God, you're right. Exactly. Yeah. Yes, it is. Because people now assume that all my software is going to run behind a fence, an armed guard, a building,
Exactly.
a cage, and then
Kubernetes is not built for that. There's no way. You've got Constellation. That's a bit.
Yeah, but they do like package everything in a VM.
Yeah.
And do encryption about
VM level. Yeah.
Because Kubernetes is inherent, not built for that sort of
Environment.
No, if you install Kubernetes and boot up the node, you've got access.
Yeah. And this becomes terrifying when you think about smart cities. When you think about retail stores with stuff under the ceiling.
It's better than Windows XP.
Is that your bar? Better way?
If you look at buses and
airports.
And ATMs.
Little things like airports and ATLs.
like CrowdStrike or something. Yeah, but they all run Windows XP still.
It's true. Yeah.
And that's not encrypted and not that is But
people are not used to computers, that's why.
No, but it's the same thing with what was the outage with the
CrowdStrike.
CloudStrike and everything.
Yes. Oh, for sure.
Woke up a lot of people from, oh my God, we're so dependent on this little piece of software
Yeah.
that can bring down the whole infrastructure.
Yeah, but all the Linux machines are just running.
Of course. Of course.
I see how this works.
Yeah, no, this works. I told you we were past this, you know? But this comes, it comes. No.
No.
Yeah.
Awesome. So you've got your product is 150 megabytes big,
The agent, the agent that we run on the edge is 150 megs. Yeah.
and it does spins up a container.
Yeah, so the kind of life cycle it does is that when you start it, it's gonna call home, and that whole call home thing. I know we have time, so maybe I'll talk a little bit about that. Is also a more complex topic than you could imagine. So most of the customers in traditionally edgy environments like industry usually have at least 2 NATs and a firewall and a very, very grumpy firewall manager that will never allow anything to come from the internet into the actual manufacturing plant, right? So there's no way you can SSH into the edge. See what I mean?
Yeah, I know.
So
Reverse SSH tunnel.
here's what we do. We do MTLS, port 443 for TCP. And nowadays, actually, for better scalability, because MTLS can be a little heavy on the server side or on the receiving side, we do QUIC, QUIC, which is a UDP-based HTTP3 thing. And to your point, what the cool thing about that is that you can start channels inside of that. So we set it up as a part of the call home thing. And then if we need a VNC window, we'll run that over that channel, over MTLS or QUIC. And the same thing if we need to start a shell inside of one of the containers, we do that over that. If we need to push container images to the local repo or registry, we do that over that kind of call home channel.
You could also do a WireGuard.
Yeah, for sure. It's a little heavier, to be honest, because, you're triggering all kinds of things. Here's a thing that if we want to poison the well a little around our competitors, and we are in some sort of POC or bake-off, we usually ask the customer, do this now. Let's say you have a central control plane running on a computer, and then you have, I don't know, we show 10,000 edge locations. Having an edge location or two go down and then come up is not a problem. But if you pull the cord out of the central environment, so you lose connectivity with 10,000 locations, everything's fine. When you put it in, that's going to, and 10,000 locations now are trying to dial home. That is an interesting challenge that kind of resembles Ethernet. Actually, you need a little bit of statistical,
in DDoS
use. Yes. If you're not careful, you're going to DDoS the living daylight out of everything between the edge environments and the server, not to mention the server itself. Suddenly has 10,000 incoming WireGuard sessions, is going to be down on their knees quickly. But yes, so we actually use, it's funny you would say it though, we use a combination of VXLAN and WireGuard for the inter-cluster communication, so between the containers in the application. So another thing that may trigger you is that we don't have a service mesh. Okay, so we literally just hook it into a VXLAN and WireGuard, and we kind of force that upon people behind the scenes. So you never express anything related to networking in our application specification, but we use VXLAN and WireGuard for that. The only important thing is how traffic arrives from the outside, so whether it's an ingress or host networking, but between the containers and between the applications, it's all behind the scenes using the VXLAN and WireGuard.
No, man. Nee, you say retail, but I can also see that the industrial solutions here.
Yes,
So with the big machines, absolutely in the field.
very fascinating, quick turn to containers, even in the most traditional environments.
Yeah, all the old machines have like an old desktop machine somewhere hidden in a compartment somewhere,
Yeah.
And the PLCs.
Yeah. PLCs.
I had a presentation yesterday for one of the leading PLC vendors called Codesys. So I had a presentation at what's called their Tech Talks about how to manage containerized soft PLCs in industrial environments. And it's a super interesting topic. And I'm all over the map. Apologies. I'm going to go back to the call home thing. I'm just going to finish this. The really cool thing, which I recognize from other parts of our beloved industry, is that there's so much pent up anger in the industrial environment towards the behemoths like the Siemenses and the Bosch Rexroths, because they have been forced to buy entire stacks. Solutions. And now they want to buy whatever industrial PC they like. They want to run whatever the Linux they prefer and then pick a PLC vendor. So you can see I'm almost violent uprising now towards more of like an IT looking industrial environment that is so interesting to watch, because that happens to all, in my mind, all calcified, all like old stiff industries. They're going to come apart in different layers. And that's happening right now with containerized PLCs in a very interesting fashion. Cool. Yeah. Yeah. So, okay.
But
Yeah.
but still,
Yeah.
So your application is really small, does networking, does a form of ingress.
Yes.
So you're abstracting a bit of networking behind, just like in Kubernetes,
Yes.
behind. So you've got a different VLAN, and you're clustering also.
Yes. So we actually use Raft for leader election. We don't need much else, and we use leader election so we can do very lightweight host failover on outage.
Do you need 3 nodes?
No.
Why not? Split brain.
Split brain.
Is
So,
that-
okay, so that's what you're asking. Sorry. So yeah. So for the general leader election, yes, 3 nodes. Sorry about that. Yeah. It's But like, maybe you solved something. I mean, there are ways to solve that with floating witnesses and all kinds of things, but yeah, we haven't done that. So no. So true. So we defaulted. We like it when people have 3 in general.
Yeah.
And then so we use it for 2 reasons. One is just failover. If we lose something, try to keep the replica count true for the
So
application.
you've got a replica account. You can run more than one. So you have also something like a load balancer in there.
So we don't actually. There's no load.
You do. What if you have 2 containers running and 1 endpoint?
So I mean, someone will have to do more clever traffic steering. So what happens mostly is that
Application.
in the application, or put a traffic, deploy a traffic using our tool, which is the chicken out we can always do, is to say, well, if you like traffic that much, you can just deploy a traffic container using our stuff. But it's not part of our infrastructure.
Okay. So you can do an Nginx on ACC proxy or
And people do, but it's not part of our solution. See what I mean? So it's in their hands, which for some customers is okay. For other customers, of course, they're a little drunk. They would rather that be part of the platform than part of their application.
If you look at Java or other applications, they've got a form of load balancing already in there all decades ago, but we suddenly don't use it because we're lazy. It's old. Yeah. Oh yeah. So like me.
Well, saying. And the other thing, so what we see is that, so of course we use DNS for service discovery. So we have DNS resolution, and we have now naming structure then, of course, for the applications and for the constituent containers. So if you have a replica set, of course, the 1, 2, or 3, or 4, or 5 will have their own DNS names, so they can do all kinds of clever things on the application layer, if you like.
Do you have also a scheduler?
Yeah.
Now, because if you talked about GPUs and different machines.
Yeah.
And in my mind, I was thinking about it's really too easy to do that in Kubernetes also, because you've got something like labels.
Mm.
So if there's a GPU in that machine, you could set a label or automatically add a label to your machine, or you can do something special there. Yeah, you have to do that yourself. But you could add a label, and then the scheduler says, I don't have that label. I will put it there.
Yes. So this is a gigantic topic. So let's go.
It's going to be a long podcast.
Yeah. So we need labels on 2 levels. So we need site labels.
Yeah, of course.
See what I mean?
But that's normal. That's the same Kubernetes.
Exactly. But then we also need host labels.
Yeah.
Because I think what's a little unusual is that we have a lot of users that have very heterogeneous clusters. They may even mix platforms. So they may have 2 Intel boxes and 1 ARM box.
Yeah.
Which, by the way, is another interesting topic. How do you schedule, you have to understand the contents of a container image to understand which platform it's built for. Or you have to build, a cross-build or multi-architecture, multi-architecture.
Yeah, but still, that's also easy in Kubernetes. You put a label on an ARM machine and tell the scheduler you can only schedule it
here.
And here with that label.
Yeah, and there's some form of emulation nowadays also.
Yeah, sure. But so okay. So
multiple things.
Yeah. So many things. Such a great podcast. Just lets me talk about things that I care about. So what we need then, a really important aspect of our system is that we need the IT team, the people that own the infrastructure, to have full control over which level of detail from the infrastructure that the application teams see. Maybe thinking about the other way around. We talk to a lot of application teams that think that they're giving too much unnecessary information and they're given too little useful information. See what I mean by that? So they want to hear, for example, in retail, they may want to hear things like, this store is of size medium and it needs visitor detection, right? So someone who knows that store knows that they have a camera pointed at the... That's not something you can see from the hardware or ask Linux about. Something will have to do that.
Yeah.
So that's
But it's information. That's much should be there. Otherwise, you need something that. Yeah.
So that's one end of the spectrum. And then there's a lot of hardware stuff that can be interesting to our to kind of the end users. And I will also admit then that we've taken a lot of inspiration from Acrino. That uses UDEV. I don't know if you looked at that project. So it uses UDEV. And UDEV actually has a neat, if you're into regex, which I'm sure you are.
Yeah. You know that?
No.
Regular expressions?
Not yet.
Yeah, that's a whole...
Regular expressions.
Oh, that's a complete. I'm Perl fan. So if you know Perl,
Yeah, for sure. I started out with Perl. That was just there Python around.
regex is awesome. But yeah,
In Sweden, we used to call that Donald Duck swearing language. Because that Perl is pretty close to Donald Duck swearing language. So with UDEV, you can use regular expression patterns and match on UDEV entries. So we use that to match into labels. So our end users can say, if you find something that matches this, create the following label. Because what they don't want to do is to go through every host manually. To remind themselves, what kind of host is this? Host number 2349. So that's literally something we borrowed, I'm making air quotes here, from the Kubernetes ecosystem, which we found to be very clever, because then they can manage that as configuration. So we have a distributed vault too, so like a distributed configuration manager. So they can literally introduce new UDEV rules live into the system. And suddenly, they can see this is an NVIDIA GPU of this model, right? Bam, that's now a label on the host and it can trickle up to the site. So, and suddenly the application teams can see that. So only deploy to this thing, that's kind of the other end of the spectrum. If one end of the spectrum is to say, you can manually configure whichever label you want, the other one, which is more programmatic, is that kind of thing. Because during the call home process, we query the Linux kernel for a lot of things in SMBIOS, DMI, and other locations. We package that up nicely in a tree structure, and we send it to the control tower, which is a pretty awesome data source in general, because then you have that, so you can match a whole lot of things.
Yeah.
You can match on the weirdest things you can imagine, and make that a declarative criteria for deployment, which is pretty cool.
yeah. Back to
It's one of the previous topics.
I was thinking about why are you running your software on the edge and not Kubernetes? That's the gist of
Yes.
it's your UDP or it's that you're small, but nowadays Kubernetes is also getting small and applications.
I agree.
Prometheus is small. Observability, you can you can send your logging centrally, and if it's gone. Sure. That's not. So, yeah, I'm still on the fence.
But I'm happy to have you on the fence.
That's good.
That's
Not over the fence.
exactly. No, you're right. And I mean, as you can imagine, we do spend quite a bit of time working in a lab environment with what we perceive to be the most promising Kubernetes alternatives for two reasons, right? One is to actually see if what we think still holds true. Is it still true that we couldn't just replace whatever we're having here with Kubernetes and then have fun and party at KubeCon like you guys? We're not invited as it is right now. Right? Oh, yeah. Because we don't build Kubernetes stuff. We can come anyway.
Yeah, you can.
We'll go next.
Yeah.
We'll go next.
And next time, London.
Yeah. And the other thing, of course, is to see what are they up to? Like, how good are they becoming?
Yeah.
And of course, I will say that, particularly in the Netherlands, of course, Rancher, K3s Rancher, is very popular. And people that are very skilled with it can do really cool stuff. So it's not that I don't think you could actually make it work, but if you want to do something like what we do, not just on a consulting level or build something for your own, you want to build something that you can actually package and that will go directly out of...
You've got your own layer above that, but I think
there's always room for both.
no. I think the smallest layer, the Kubernetes layer, is. I think it's almost the same, but you've got your management layer above that provides value, and it's the thing more, because Kubernetes is not management. It's not a management layer.
Thank you for saying that. That's a fine point. Actually, it's an important but nuanced point. So
You've got applications for that. Kubernetes is an API.
Yeah.
That's
that too. Yeah.
That's the only thing it is. It's an API, and applications can talk to it.
Yeah.
That's it.
Yeah.
That's more than that. Yeah.
Yeah. But I think let's see if I can take it back. So when we think about things like this, I personally like to think in abstractions. Like if you look at the Kubernetes API, the core API, I know we can extend it with CRDs. You can make it play tic-tac-toe and all those kinds of things. Do most of that. That looks like something actually came up from your mind. A tic-tac-toe resolver for Kubernetes.
Yeah, I want to build it.
There you go. When you look at the abstractions for the applications, right, it wants you to think, for lack of a better way of saying it, it wants you to think in a particular way. It wants you to think in pods and applications and daemon sets and all those kinds of things. And the problem for us is that that's not how we think people should think about applications running in edge clusters. That's as simple as it gets. And worse is that it's really hard then to build an appropriate and nice abstraction in a centralized fashion, if that's what you have to play with. It cuts closer to the Docker APIs, because as you can imagine, our agent that actually speaks to the Docker APIs or the Podman APIs or the Podman way of, and then we do a little bit of networking on the side, because the abstractions of the container runtimes usually don't involve enough networking for us. And if we were to think about how to do that through the Kubernetes API, we would lose so much. We would lose so much control, and we would lose so much kind of basic features that we believe are key and important here, for really reasonable reasons, because Kubernetes was never built for that kind of management plane on top of it, right? So I, in no way, shape, or form do I blame the clever people at Google, of whom we've talked to most of them. They built something awesome for that environment. They built beautiful abstractions.
It's cloud.
Yeah. And it's cloud.
It's cloud software. Cloud native, cloud software.
Exactly.
Not edge software.
Right. Exactly. And so if you have two of those, that's awesome. You have failover and everything. If you have 5,000 Kubernetes endpoints, you're suddenly in a whole different world. And you want to do canary-based, deployments, and then rolling cohorts across the clusters and all kinds of things. It just starts deteriorating, because it wasn't actually built to support that abstraction or that way of thinking about.
But I do believe this is a story that's good fit on the KubeCon,
Yeah.
But yeah.
But where can they find you?
So avasa.io, I guess, is the entry point, and there's a big blue free trial button for people to push.
Awesome.
That will give them an actual kind of edge setup with a couple of sites and our control panel and all that kind of stuff. I'm Carl Moberg. Hit me up on LinkedIn. As you can probably tell, I love talking in general.
Me too.
And I love talking about things like this. So I'm always happy to hear about various and sundry things, including nuanced and constructive reasons why we should reconsider Kubernetes, or, I love that.
We will get back to you about that.
I'm making new friends here. I love it. Yeah.
Okay. For our final question,
Yeah.
and I think maybe you answered it already in your story, but what would you like to see in the future about Kubernetes?
Yeah. Can I get to answer?
Yeah. So sure. You always use the metaphor. I could put a crystal ball on this table, but it's a little bit too small to put here the crystal ball.
Yeah.
But what would you like to see in it?
I would love to see people calm down a little bit. So that's the first thing. Literally, calm down.
That's a new one.
In which way?
So what has happened here, which I think is hugely interesting, is that a lot of people have invested their entire career in a single tool. which I think degrades the quality of the conversation. And take that from someone who has worked at Cisco, a company that was very good at doing that. And you could clearly see that the nuances in the conversation go away if people have their whole career banked on a single tool. So I think that is actually, and I of course I'm biased. Of course this is a bit biased.
Yeah, of course.
I think for the industry, if people could just calm down a little bit around Kubernetes and try to not, put their whole career's weight on that as the only tool, I think that would be good in general. Second, I think in general for Kubernetes, I think that focusing more on specific aspects of the runtime environment, I think would be good. I see vendors do that. I don't know if I should, maybe you tell me if I should have hope for the Kubernetes project to be a little more focused and less all over the place and kind of decide what they want to be. This might be swearing in the proverbial church, but it's just give us a more well-defined and expressed core set of abstractions and use cases, I think would be beneficial. Maybe that would even open up for us a little better to understand, well, how could we take this on? Because as you can, the backside of this is in many conversations that I have around this, people just say, just write a CRD, just extend it to do whatever it was never meant to do. And to me, that's not a good direction, Janet. That's just,
I don't like the CRDs. It's building a.
see, you don't like Helm charts. You don't like CRDs.
I don't know. I'm like you. Yeah, I always say I'm old school. I like Unix.
Yeah, so do I. So do I. Yeah, so do fewer things better. I think is the other.
But that's not the. I understand where you're going, but Kubernetes is not. Is never gonna be that thing in the box.
Okay.
It's always gonna be
framework.
yeah. Do what you want with it.
Yeah. Is that a good thing?
I think so.
Yeah.
Yeah, I think so. Like
And honestly, I'm asking not because I want to trick you into a corner. And I'm curious.
I think so.
Yeah.
Because if you look at Linux,
Yeah.
is Linux a box thing?
No,
It's
a little broader than that. Yeah. It's extensible for sure. It's being used to all kinds of things.
yeah, it's there.
Yeah.
And yeah. And
But on the
I
other
don't think about Linux anymore.
No.
You've got- no.
But maybe you could argue that Linux at its heart, and I know you'll love this, is an implementation or something that looks like the implementation of POSIX. And that is the stable core of it, right? And everybody expects that to be present, and that's what they use it for. So, and there's nothing, well, in my mind, there's nothing like that left almost in Kubernetes. And you must have met so many vendors that say, okay, so we're going to deploy our stuff on Kubernetes, and they literally don't use any of the Kubernetes parts of the API. They have 5 CRDs, right? So they kind of short circuit the entire core of Kubernetes for their own purposes.
Yeah, that's
It's
like
like, oh my God, that's a vendor lock-in strategy if I've ever seen anything. It's just that it comes through an API that belongs to an open source project, which weirds me out every time.
That's an interesting way of looking at it. Yeah. Vendor locking with CRDs.
all the clouds could vendor lock-in.
Absolutely. I mean, I was also so. Have you guys watched the Kubernetes documentary? You know, that 20-minute thing on YouTube.
No, we're noticed about that one a while back.
You should have a movie watching podcast episode where you watch
a comment. That's a nice one.
like a comment video on it. Listen intently to what a gentleman called Joe Beda from Google says in that documentary on why they started pushing Kubernetes. I think you'll find that entertaining.
That's big money. But yeah, that's
A grandiose power move.
yeah.
And they did well. They did super well. I mean, they must have just overshot every goal they put themselves to.
Probably yeah. So
Yeah. Carl,
Sure.
thank you so much for taking your time to have this chat with us.
Thanks for dragging me here. I really enjoyed this and appreciate it.
Yeah, and we'd love to talk to you again in the future.
Sure. Let's do it.
Okay.
let's have it.
Thank you very much. Bye.
Bye bye.